Page 510, number 9. For each graph of f of x and g of x, determine the equation in the graph of f times g and f divided by g in the domain and range. So first of all, we can work out the algebraic expression by actually multiplying these functions together. So f times g is going to be x plus 3 times negative x minus 4. Okay, so this is a parabola. So the domain of this is going to be x is all real numbers. And the range of this will be where the vertex is, and we could expect the vertex to be the most negative. And it looks like here we have it's going to be at x is equal to negative 3.5. And so I'm going to maybe put that in my coordinates here, negative 3.5. And plugging negative 3.5 into here, I'm going to end up with it looks like it's going to be negative 2.5. Okay, so yeah, it'll be negative and negative, so it's going to be positive 2.25. Okay, so that's where one of my vertices is going to be. It's going to be somewhere around here, and that affects my range. So y is greater than or equal to positive 0.25. Okay, so that's the first thing. And so it's going to be less than, because that parabola is going down. Okay, and so that's going to be positive. Okay, so it's going to be, my coordinate's going to be there, and it's going to be going down. So that determines my range. Okay, so to work out the graph of this, what we want to do is we can, first of all, use the graph to get our zeros. So at negative 3.5, so sorry, negative 3.5 is over here. That's my coordinate. And negative 3, negative 4 are going to be some coordinates here. I can use my graph to be able to get me some other coordinates. So I'm going to use coordinates at x equals negative 5. So I'm going to use those 2 points here. So it's going to be negative 2 times positive 1. So negative 5. It was negative 2 times positive 1. So I'm going to have coordinate negative 2. So it's going to be a point here. And then I'm going to choose another point over here, a symmetrical point, and I'm going to have a point at negative 2 and negative 2. So negative 2, negative 2, and that allows me to draw that graph in. So my graph is going to be this parabola that looks something like that. I could work on a y-intercept again by using these coordinates here, multiplying them together. It'd be at negative 12. And we can get a series of coordinates by just taking the y values of each function and multiplying them together. For the division part, if I'm going to divide these two functions, when I divide these two functions, I get f of x is going to be x plus 3 over negative x minus 4. So at x equals negative 4, I'm going to have a domain restriction. So x cannot equal negative 4. The range of this is going to be based on the horizontal asymptote. It looks like there's a horizontal asymptote at negative 1. So we're going to say that y is not equal to negative 1 as my horizontal asymptote. So that's going to be my range restriction. To give myself some values here, first of all, I'm going to draw my vertical asymptote at negative 4. So at negative 4, we have a vertical asymptote. So I'm going to, at negative 1, I'm going to have a horizontal asymptote. And I'm just going to plug in a couple coordinates. So for example, negative 5. When I divide the coordinates at negative 5, I'm going to have negative 2 divided by positive 1. Negative 2 divided by positive 1 is going to give me negative 2. So I'm going to have a coordinate here. So it looks like the graph's going to pass through this point like that. Okay, maybe I'll draw a little bit better than that. So it's going to pass through that point more smoothly like that. And I'm going to choose a point at -3. And to get a y-coordinate at -3, it looks like it's 1 times 0. So it's going to be at 0 here. So then it's going to follow the asymptote here and then follow the asymptote this way. So using those couple coordinates plus some references, recognizing that this is a rational function with a horizontal asymptote and vertical asymptote helps me get coordinates for the graph.